want to do regression. Now here's the thing. How many of you have the data analysis package in Excel? Gotta be more than one, hopefully. The last class there were a lot more. What I would do is go to data, right up here. You can download it, and I'm almost positive it's free. It's free to do, right? So you need to add this module to Excel. If you want to do it, I don't know if they've got it here on myslu.edu, the free software you guys download from time to time, or I think you can just go to Microsoft and just upgrade to it. But you want the data analysis part, all right? So I go there, and I'm going to do a calculation here. Data analysis. I want to do either correlation or regression. Just do regression. Okay. Then it's like, well, what's your Y range? Y is independent or dependent? Dependent. And I'm saying sales is dependent on these things. Okay. So I want to click over here. It says, what is your dependent variable? I'm going to say sales. Okay, so I hit enter. Boom, it loads that range. Then it says, what's your independent? Maybe I want to see if sales related to income, maybe. Okay, and I want a line fit plot. And I want labels. See, I can set a confidence level here. I don't know if you can see that. It's awful small. Here it says confidence level. See what you get when you pay the same tuition as everybody else? And you sit in the back row. I mean, if this were a ball game, you'd all be sitting in the front row. Right? You'd be like, oh, I want to sit up front, you know. What are you doing? I shower. I'm good. Look at, nobody's going to read this. Whatever. And anyway, new worksheet, residuals, standard residuals, line fit plots. So we're going to do this, and it's going to calculate this out with regression. What it's going to do, because I didn't say a new worksheet or I didn't say new workbook, it's going to put a new worksheet in here. So I'm going to click OK, and it's going to go there, and there it is. Okay. So here, this is all generated by Excel. Let me enlarge this as well. Okay, here's my nice chart. And based on the P factor, the P value, does income affect sales in this example? Does it or doesn't it? And how would you know? This is what you're going to have to write about your your homework. We have homecoming this weekend. We have homework as well, with home stuff and home sales. What does it say? Does anybody know? What does the P factor say with regard to income and how this independent variable affects home sales? Is it showing a relationship or no? No. How come? How do you know? Low P, it's 0.05. No, it doesn't. One other thing that you can do as well that I want, and I mentioned this, I gotta remember this, I'm kind of jumping around here, but you go to the data points and right click and say add a trend line. Boom, there you go. I want that in there as well. Okay, and what it's showing is the trend for predicted sales, where the actual sales are, and the distance between the predicted and the actual. It's saying I'm not seeing a lot here. This is what I would predict based on this. This is where the actual data points are. I'm coming back here and saying there's not a whole lot of correlation there. Yes.
So if you put your line in, is a steeper slope or a steeper line a higher correlation?
It is on correlation, not so much on regression.
Okay.
And the regression is where you get the trend and then you get the data points that fall away. You know that difference from the norm, and then you get into this difference squared, R squared, and there's a lot of things going on that I'm not going to get into in this class. We're doing marketing analytics, and I'm just going to show you what we need to know to get through this. Okay? Now, I could do multiple regression. That's just one independent. I could do this.
Intercept? Did you what is that?
The B intercept?
No, the P intercept, like above the 0.05. like the p-value right underneath that.
Right here?
The one.
The intercept, yeah, you just ignore that.
Oh.
That's just where it would fall on the line where it was
Oh.
0. Don't worry about that. Worry about this, your independent variable. We're trying to see how that affects the dependent sales. Now, back to this, I could have done data analysis again. Gotta have that module installed. You have to go to the data. You can go data here, depending on where you've got it. I'm gonna do regression. I'm gonna do okay. And I'm gonna try and get one calculated with sales again. That's good. I want that. Now I want to do them all at once. And labels, line fits. Now see what we get. Oh. Oh, it took the wrong thing. Darn it. I don't know why it did that to me earlier. Boom. It reset it somehow. Now I'm gonna go here. Boom. Didn't do it twice last time. Now let's see what we get. So now I'm looking at all of these at the same time as independent variables and how they affect sales. Wow. So looking at that, what does the p-value show us now? As a marketer in analytics, what does that tell you when you pulled all that accounting data together and ran it against the dependent variable? What does it tell you? I know, you're looking at the clock. 10 more minutes. We just sit here 10 minutes and not answer what this is. What does it tell you? Come on. There is. Between what and what? What apparently affects sales tremendously?
Population.
Population does. Thank you. And what else? Homes. So there is, when compared with others, income changed with multiple regression. And so purchases is 64, not really a lot going on there, but if I want a 90 or to a 95% confidence value, I definitely say population affects sales, no duh. The more people there are, do you think a Domino's in Wentzville sells as much as a Domino's in St. Louis, or, maybe it does, but I mean, it depends on how close they are. But if we had one Domino's in the entire city of St. Louis, which has 330,000 people, and one Domino's in Wentzville, which has 30,000 people, I would expect you'd sell more. So in this example of just data that I copied and pasted random stuff, again, random stuff, I did try and match some of it so we get a good p-value. You'd see that, yes?
So for the confidence value in this one, is it 95% then?
Well, you are 95% confident, yes. I am 95% confident that population definitely impacts sales.
And then
Definitely.
it still comes up with that 95%
On its own.
Figure out.
Nope, nope. The regression model pops that out, that p-value out for you automatically. Yes?
Why did income change so much?
When considered with other values compared to that, that's the reason multiple regression is so important when we have resources and all these things that we do. You throw them on all in, and it looks like it affects it more than it did by itself based on other factors. It completely recalculates everything. It uses sales, what they are, and compares them to where they would be based on the forecast, and it modifies it. It does it. When you do multiple regression, it changes the values. Absolutely. Yes?
So in the communication part of this graph, would you include the other?
Yes.
Resources too?
If you did multiple regression, and I'd say that based on these observations, 95% confident that population, so what would that tell me as a marketer? I mean, again, this is such a basic example that I would want to go into bigger markets with bigger populations to affect our sales. Well, I mean, I can't affect population, right? Other than selling a bunch of bad birth control devices in the market, so that there were more people having babies or something. But other than that, I couldn't really affect that. But it might tell me where I need to go in terms of markets. Again, there's a bit of no duh with that, with the simple data, like, oh really? Bigger markets sell more products. But somehow 93% confident that the number of homes in that area also affect the sale, which might also be directly related to population as well.
Do we need to look at any of those other
Nope.
statistics?
Nope.
besides